In the last episode, we have already watched the origin of geometry and a short intro about Greek mathematicians Thales and his friend Pythagoras. But if you haven't watched the last video, you should watch it first. The link is waiting in the description. And now I'm gonna show you the father of geometry, Euclid. You may ask that Thales, Pythagoras and many more mathematicians had already begun the learning of geometry. Then why is only Euclid considered as the father of geometry? Well, if you watch this video till last, you will accept it. So let's begin. We know from the last video that the geometry is the measurement of land. But is this geometry means only measuring the land? No, it's far more beyond as we all know. Actually, it is a picture maths, as it simplifies the complex equations in algebra by pictorial representations, about which I'll tell you later. Now, as we all know, that the ancient Greeks were trying as hard as possible to prove several statements. But what is interesting about these developments of geometry was that they passed this knowledge from one generation to another generation, either orally or through palm leaf messages or by other ways. So before Euclid, every discovery was scattered here and there. The knowledge was not well arranged. But then Euclid, who was a maths teacher, started collecting all known facts and discoveries and works on geometry at that time and arranged it in his famous treatise, and he named it Elements. It had 13 parts. He named every part itself a book. If you want to read this book yourself, you can check out the description. I have provided the link given below. This book was a boon for geometry. In his book, he taught about all the statements which he discovered by looking his surrounding. He looked around his surrounding and studied various shapes, and then he wrote his discoveries in the book. In it, he told about some definitions, some postulates, some axioms or common notions, and several theorems. So what these terms are, you may ask. Before telling it, I want to tell you its base, which is statement. So what statements are? So basically, statements are the sentences which can be judged to be either true or false. So from here, we can say that statements are just sentences which are either totally true or totally false. If I give you an example, so in ancient times, people believed that the earth is flat. This sentence, that the earth is flat, would not be a statement at that time, as they were not sure about that. How can we decide the earth is flat until we have any proof or we see the complete earth from space? So this was just a simple sentence. But after we got several proofs about that the earth has actually sphere shape, then if I say that the earth is actually flat, this sentence is a statement, and specifically this is a false statement as it is false. On the other side, if I say that the earth is likely sphere shape, then this is a statement too. And yeah, that's a true statement as it is true. So from here, we can conclude that the statements have only two types, a true statement and a false statement. And in mathematics, false statements have no use, as why we need them if they are false. On the other hand, only true statements are helpful for us, as they are true. So now let us see how this true statement will help us to understand axioms, postulates and theorems. So these true statements are actually of two kinds, which are universal truth and a truth with proof. Universal truths are nothing but the axioms and postulates, and on the other hand, theorems and corollaries are the truth but with need a proof. So what these terms are, I'll tell in the next episode, as I don't want to exceed the length of this video. So that's all for today, and I'll see you guys in the next video. See you then.